Hello, ladies and gentlemen. In our second video, we are going to talk about the developments in our carbon monoxide security system capstone project. We had to make a few changes in our initial design scope, but after all, we're trying to achieve the same initial goal. For the changes we did, they were mainly in the design and the programming departments of the project. As my colleagues discuss, we have changed the type of sensor we're planning to use because of health issues and demonstration purposes. And we are giving the programming language multiple choices to choose from. To go into more details about the design, I will leave it to Ahmed Al-Mazmi.
We now have an overview of how our final demo design should operate. The design will simulate a sample house security system. The system should be able to detect the carbon monoxide in the room, then start a sequence of security measurements. The whole system will be installed in a transparent container that will simulate a room. We have decided to use a carbon dioxide sensor instead of the carbon monoxide sensor for a number of reasons. Firstly, carbon monoxide gas is a dangerous gas to work with because it's hazardous and flammable. Secondly, it will be hard to get carbon monoxide gas for the simulation. And the actual sensor is more complicated and expensive to get. Finally, it will be hard to demonstrate the testing of the sensor since unlike carbon dioxide, carbon monoxide gas is colorless. The components that will be installed inside the container are going to be a CO2 sensor, a buzzer, LED lights, which will represent the house backup lights, fans, an Arduino Bluetooth device attachment, and an Arduino. The system will kick off when the sensors detect carbon dioxide by activating the buzzer and a notification message to the owner of the property and local authorities, as well as turning off all electrical and gas appliances. And for the programming section, my colleague Abdelhadi.
As my colleague Ahmed already mentioned, we are going to be switching over from a carbon monoxide sensor to a carbon dioxide sensor. We already mentioned in our previous video that we are going to be using the Arduino program code. This was subject to change based on which sensor we decided to use, and after the change was made, we collectively decided as a group to start studying how to code on Python. Starting next semester, we'll be programming on both Arduino and Python. This may be time consuming, but this is beneficial to us. After all, we didn't spend as much time researching carbon dioxide sensors as we did carbon monoxide sensors. So having two different platforms where we could code on is gonna help us, especially since these two platforms like Arduino and Python have pros and cons. We can easily weigh out these pros and cons, and we can find which program is going to be the most suitable for our project. And finally, I'll pass on to my colleague Abdullah for a little bit about the market.
Okay, as for the market research, there are a couple of companies that specialize in designing and installing carbon monoxide sensors. For the customers, however, the cost is different. Some companies provide you with the system, but then the consumer will have to abide by their yearly plan and pay monthly for their monitoring, such as AD and Nest. These security systems are limited to having just sound alarms. As for the sensors, they cost around $20 to $60. The plan is use sensors and parts that are currently available in the market to cut down the price and to focus on other things such as the programming and building the demo. Thank you all for listening.